Okay, for Overhill, we have to think back to the 70s and all those cool car movies and TV shows, you know, like The French Connection and Adam 12 and Bullet. And, you know, they would always like drive real fast downtown and then fly over the hill. So the question this time is, how fast and stay on the road? So here's your hill, usually the streets of San Francisco because they have the best hills, and your car's coming along very fast, right? And the question is at the top, how fast can it be going without flying off? Car, mass, etc. That's what we want to know. So it's very similar to the last problem, but just it's the opposite. We want to stay on the track. We don't want to fly off too high. Okay, and again, we're going to have downward be the positive direction just to make it work out, make it pretty. Let's see, it's a physics problem. We're going to do a free body diagram. Here we go. So mg is down. We got one force down, but now the normal force can only push up. Right? So now I'll draw my normal force like that. So the normal force is in the negative direction this time, while mg, the weight, or the gravity is in the positive direction. So we'll set up sum of the forces equals ma. We'll assume that it is circular motion at the top because the forces are down and the velocity is to the right. So the hill has some effective radius r from the top like that. Most hills are not actually a circle. That would be a weird hill. And some of the forces. So we have mg, that's the positive one. And now here's the weird part. I'm going to write plus n, because I'm going to later say whether n is positive or negative. Right now I'm just going to say plus n. If I put minus n, then suddenly n is just the magnitude, and we're artificially making it minus. I want to let it become negative. I want to require it to be negative later. So for now, we have the weight down, we have some normal force, and that's equal to mv squared over r, because it's circular motion. Right? And just like before, we know that this is constant, and this is due to circular motion. And we can sort of go through the thought process. You know, if you go slow over a hill, when I go over a hill, being a very safe driver, never been pulled over in 30 years, I go slow, I never fly off, right? Because I go slow. So if you go slow, this is really small, all right? And if this is really small, then you have plenty of force to keep you from flying off, except they're opposite directions, right? So if this is really small, you need this to be small, but you have a big force here, but you have a 0 to any force you need here to cancel it. So it's easy to have a small force here, because n cancels mg. But this is really big. If you fly over really fast, you need a big force pulling you down, right? N can go all the way to 0, and then the only force you have is mg. So if mg becomes not enough to make you make this circular motion, then you'll fly off. So it's the opposite of Underhill. Here we have the case variable but this is the big part, only negative in this case. It can only be negative. Right? So the maybe intuitive way to solve this is to say, well, it's just the case where n equals 0, and you solve it and you're correct. But again, let's do it a little bit mathematically. If you like it intuitively, then you're done. We'll see you in the next video. But if you want to see it mathematically, here we go. We're going to solve for n, and this comes over here, and it looks very similar to last time. You get that n is m times v squared over r minus g, like that. Right, that all looks right. But we're going to say, but this time n has to be less than or equal to 0. Right? The normal force has to be negative. The normal force can only push up in the negative direction. It could not push up at all. It can be 0, or it can push up, but the normal force can never pull it down in this case. So if the normal force has to be less than or equal to 0, then this term has to be less than or equal to 0. M times v squared over r minus g must be less than or equal to 0, so the mass goes away, this goes over there, and you find that v, once I take the square root, and don't panic about the square root, must be not equal to, must be less than or equal to the square root of gr. Okay? So 1, that makes sense. The velocity has to be slow, so you don't fly off the hill. You go too fast, you go greater than gr, then you'll fly off the hill. Square root of GR. And you'll notice that it's the same answer as Overhill. Overhill and Underhill, they're both the square root of G times R because they're both this critical point where the normal force equals 0. They're basically both where you're simply equating mg equal to mv squared over r. But you got to think about the nature of the normal force to really see it physically and mathematically.